Hello, my name is Larry Liebrock. I'm a visiting professor of computer science at the College of Science and Engineering at Idaho State University. I'm also a research assistant for Idaho National Labs Cyber Corps. My professional and academic specialties are cyber security, focusing on cyber threat intelligence, and also digital forensics. I have over 30 years of experience in this area. However, what's most important for me to tell you is I really enjoy teaching. Teaching is one of the important gifts I think I give to my students. I frankly learned from many of my students a lot of information. I really enjoy teaching. I have the best job in the world. I teach small classes at Idaho State with very intelligent students in computer security. I also get to work with Idaho National Labs, which is on the forefront of cybersecurity issues in cyber-physical systems. There's world-class work here, and I get to bridge that between academics and research. I worked for HP for a period of years and then discovered that my computer had been hacked. This was, at that time, was a relatively uncommon occurrence. I went to the Hewlett-Packard security officer and said, gee whiz, what'll I do? And he says, I don't know, fix it yourself. So that was my first calling in terms of computer security. The short story is it took me 6 months to make the case. I gave the case to the FBI, and the guy was prosecuted. Of course, IT is an interesting area. Most of us are familiar with IT. IT example is your computer. You're simply a human being interacting with your computer, sending digital signals to a server back and forth. That's an example of information technology. There's another area called operations technology, or OT. It's also called industrial technology. We can spend a lot of time thinking about the precise and rigorous term, but I just would like you to think of operational technology as the interplay between an analog device and a digital device. In other words, your computer is talking to a sensor, it's talking to something that's getting physical information, and maybe communicating to other systems. There's no necessity to have human involvement. It could be machine to sensor or machine to machine. Now, these are abstract concepts. I'd like to give you some examples. When you get older, you have cardio insufficiency problems. And I have cardio insufficiency, and the Veterans Administration asked me to go have my EKG taken about every 90 days. I live in West Texas, and it takes me about 3 hours to drive up to the clinic. I go up there for a 10-minute test. The doctor reads the EKG, and I spend 3 hours driving back. So I've spent basically 7 hours of my life. Now, I was asked to participate in a test. This is a cyber-physical system. This is an electrocardiogram. You simply place your thumbs on this. It sends the data over the internet, encrypted, to a server where there's an artificial intelligence machine that looks at my EKG and gives the doctor either a green light or red light. This is a telemedicine technology. This is a cyber-physical systems. These are going to become more and more apparent in our lives as we make use of telemedicine. We see tremendous growth. There's going to be, they're averaging 8 to 10% a year. And of course, we need cybersecurity professionals to manage these systems. As of today, according to my search on the internet, there are approximately 55,000 cybersecurity positions open today. It's really important that organizations like INL, like Idaho Power, have students who can plug and play in that particular environment. My job as an academic is making sure I can look at the trajectory of technology and also ensure that our students are getting the skills they need for effective jobs in 2025, 2030. I invested a lot of time during the pandemic and reframed how I can better engage students in dealing with the complexity of cyber-physical systems. I decided that it was time for me to experiment with a different pedagogy, a different way of teaching. The idea is we're going to learn by teaching. I designed this experimental class called CS4465, which is Special Topics in Cyber-Physical Security, as a 3-phase class. Phase 1 is a foundational understanding of cybersecurity systems, their architecture, their threats, and the risks associated with them. Then we will move to the second section using a U.S. government-sponsored publication called Structured Analytical Techniques, which focuses on applying these techniques for the analysis of cyber-industrial systems. This was developed by the CIA and has been proved very successful as an interdisciplinary analytical tool. The third section, which is perhaps most important, a team of teams, which will be composed of undergraduate and graduate students working with subject matter experts to really focus on teaching by learning this particular course that they will teach a 1-hour class, videotape it, and then and present it for instructional use. This is an exciting time. This is an exciting time for me personally because, as I said earlier, this is the best job I've ever had. I get to work with really smart people, both from Idaho National Labs Cyber Corps, and I get to work with great students. And I really want to engage them to take advantage of this time to rethink how we're doing and to rethink how I can best engage you in understanding the complexities of cybersecurity systems.